so there's a loss of energy because of friction and heat production. But overall, you try not to. And there's this fun fact, and I forget it. I mean, specifically, I forget the number. But as you can imagine, you are not eating ATP. That represents your energy, but you are not eating ATP. You're eating food which can be converted and broken down to form ATP. The energy loss when you break down food, that loss of energy, you see that delta G is negative right there when you break down your food. You take that energy and use it to go backwards to regenerate the ATP that you have just broken down. So this is you at CC's right here. You're eating and you're breaking down your food, your delta G is negative. And you're regenerating your ATP. This is the event at the restaurant. This is the event on the football field. Every muscle movement you make, you have to break down ATP. After you break it down, you have ADP. So what do? You recharge the molecule by eating. It's like your phone. This is my phone right now. ATP's high. I've got full battery. Can you see that? No? It's full. It's recharged. Over the course of the day, I'm going to use this thing, right? Is it going to use energy to work? Okay, so it's going to be burning all the energy that's inside of it. Now imagine if I took it home and I didn't put it in the charger. What can I expect tomorrow morning? It would not work. You have to be recharging, in the case of a phone, plugging it in, or in the case of ourselves, do we get plugged into a socket? No. So we have to be eating, taking that energy from the food, and using it to recharge our batteries. Yes, sir?
You said the negative means it's releasing, so the positive means it's adding.
It's taking in.
Taking in what?
Energy.
So, I mean, I guess, what is the 7.3?
That's how much energy it has to take in.
So release is the same amount that it takes in?
For ATP, that's correct. It's literally a reverse. And that's the same thing. This has energy in it, right?
Yeah.
This has no more energy, nor does it have no less energy than the energy that it got from the socket.
Yeah.
It just didn't randomly make it. I mean, it shouldn't be randomly losing it. The energy before and after should be equivalent. In other words, however many kilowatt hours, or I guess that's how you would measure it, I suspect, that I sent to this phone last night. That's how much is in there right now. Yes, sir.
Is it like if I wanted to do something big, like my bed, I'd have to take it apart to move it, and then put it back together later to actually use it? Kind of like that? Not at all.
Let me think. To me, not really. I mean, it's all about it's kind of one of those things where I view it like money almost. I have money, I give it to Jamie, and now I'm out of money. Right? Fortunately, it powers my needs my things that I want. So at the end of the day, I've done stuff, right? I've gone to the carnival or the fair or whatever it is these days, but I have no money left. So what do I have to go do? I have to go to work, and I make some money, or I make a hand, I do a good job, and that helps me to regenerate my money. They pay me. And what do they pay me for? So I can just stare at the money? Use it. It's like, why do you eat? Does it taste good? Now, why would it ever taste good? Why would this event ever be such a thing that you enjoy? Because it's detrimental to your body? Have you ever thought about that? If you poll people, what do you think they like the most? Do you think they like a salad, or do you think they like a fat, greasy burger? Tell me the truth. What do you think people like? No, they do. Do you know why that's the case? There's more energy per unit, per pound, per kilogram, per mass, per gram in that hamburger than there is in the salad. Am I correct? It's an evolutionary thing. We would go after the food that would generate the most energy for us. Simple logic. People like sweet stuff, don't they? Which has sucrose, right? Table sugar. Have I mentioned that to you before? What are the two monosaccharides of sucrose? And which one of those don't get broken down too well? And what does it go to? High energy molecule. If I work and I've got this guy over here that offers me 5% interest a year for 50 years, and I got this guy over here that offers me 25% interest each year. Who do I go with to invest my money? The bigger percent, right? You go for the best bang for your buck. That's why we go to CC's, guys. Do you understand? Now, as you can see, you are not eating new ATP each day. You're eating new food each day. And you breathe out your carbon dioxide. You realize that's what you're breathing out, right? You breathe in O2, and now you breathe out CO2. Where's that carbon coming from? Your food. There's the carbon. What's left? A 2-for-1, basically, of hydrogen and oxygen. So you make some water. Yes?
I don't know how to ask, that sounds stupid, but, so with that, are you saying, so can people have different amounts of energy, say, saved up or something like that?
In fat levels, yes. But honestly, as your body becomes larger, and I mean like more muscular, as you build up endurance and size, then the amount of ADP and ATP in your body would increase significantly. Absolutely. That's why you can have a guy that can move whatever, and another guy can't. It really comes down to how much energy do you have ready to burn. That's what it really boils down to. But you're not eating ATP every day. Do we understand that? You're eating food every day, which can be used to regenerate the ATP that you've lost. So ATP and ADP are randomly associated in your cell. Right? Right now, I should have a lot of ATP because I just woke up. I burned my food off from last night. I made some ATP. This is going to power my day. What will it be like when I get home at about 12:30 tonight? Like that? What will I need to do? Plug in my phone, eat a sandwich, so I can repeat the next day. Now, I broke it up into like this term, this idea of like, in the morning there's a lot of this, that's actually false. This is instantaneous every second. You regenerate about 30 pounds of ATP a day. So that means that you have only maybe a pound of ATP in your body, but 1 minute it's ADP, the next minute it's ATP. That means have you heard the doctors say like, you need to be eating like 4 or 5 meals a day, you shouldn't just eat one? You've heard this, correct? Do you see how I've drawn my arrows here? This is an animal thing. It's also plants too in their mitochondria, but it's mostly us. If I reverse the arrows and we read it from right to left, you'd be seeing what plants do. They burn energy to make glucose.